All right, hi everybody. This is the recording for, or the demo for BioCSRL. So as you can see, we got a lot of really awesome coursework done for this hackathon. About 3 or 4 different courses now. So we have a ChIP-seq course, we have an RNA-seq course, we have the original single-cell RNA-seq course, and we actually have a really cool course that's mostly geared towards neuroinformatics that shows you the differences between single cell RNA and single nucleus RNA. So yeah, we'll be going over some of the courses now, and so you'll get to see them.
He was busy on the FASTQ downloads and the pre-processing stuff. And the part that we're starting here is the processing of the gene counts. And then the lesson that I just pulled up is a lesson to kind of have a first look at the RNA-seq data after the gene counts have been pre-processed. So the first thing we're doing here is calculating distance between our samples. And then we are working on making a little heat map to look at the distance for our samples. We're learning to heat map first. And a figure created here. And then the follow-up question asks a little bit about the what the students can see in this heat map, and then they can enter an answer here. And then the second part of this is understanding principal component analysis. So they get to plot a PCA plot.
We thought one area of single cell data that people are working on a lot is in neuroinformatics. And if you're working with tissues like brain tissue, a lot of times you'll use single nuclei RNA-seq as opposed to single cell RNA-seq. And there are most workflows are based on single cell RNA-seq. And so we wanted to highlight some of the differences between single nucleotide RNA-seq and single cell RNA-seq. So that people are aware of those when they do quality control and analysis downstream and look at those data sets. So there's this great data set that's available that has both single cell RNA-seq data and single nucleotide RNA-seq data. And so this lesson goes through just some of the background of that data set and some of the things that are different, like mitochondrial, ribosomal RNA content, the number of genes you find in your data set, the number of reads that map to exons and introns, and some things that you might want to know when you use Seurat or other packages.
And so yeah, the next course, which was done by Matthew Moss with our team, actually covers a ChIP-seq workflow, which is really awesome because it's totally bioconductor based, and you get to go through the raws all the way to the peak calling and annotation, which is really nice. All right, so while we're going over this ChIP-seq footage, I also wanted to give a huge thank you to the team who made all of these courses happen. It really just elevated this project and made it feel super real, and they were just incredible throughout. So really big thank you to Julia Philippe, Nikolai Von Kugeglin, Elizabeth Hudgens, Benson Lee, and Matt Moss. This was a really amazing all-star team, and I cannot stress how much work they did. So thank you so much to all of you guys who saw the vision of the project and who made it your own. Thank you.